What's up, everyone? Trevor is back here with another AP Calculus rapid review video. Today in this video, we're going to be covering the topic of derivatives, and my goal is I'm going to teach you everything you need to know about basic differentiation rules to ace the AP Calculus exam, and hopefully I'm going to go ahead and do that in less than 15 minutes. That's the goal. I'm going to try and teach you everything about basic differentiation in less than 15 minutes. Before we get started, as always, make sure to remember that if you're confused on what I go over this really fast so I can keep this video as short as possible. If you're confused and want more help, check the bottom right-hand corner of the screen. Inside this white box, you'll find what the big ideas are, and you can go through my AP Calculus content playlist and watch the videos that you're stuck on using the keywords in the white box. So without further ado, I'm going to go ahead and let's get started. If y equals e to the x cubed, find dy dx. So we're asked to find the derivative of this function. There are two things you've got to know. For one, you've got to know that the derivative of e to the x is e to the x. And number two, you got to remember the chain rule, where there's two, you can see there's two functions, and so you've got to differentiate each function. And like an onion, you got to peel your way into the center. So you're going to first take the derivative of the outside. The outside function is this exponential function. So e to the x is simply e to the x, but you leave the inside unchanged, and so you're not going to change this x. You're going to leave the x cubed as it is. So you have e to the x cubed, but then you're going to multiply by the derivative of the inside function. And the derivative of x cubed, well, you're going to bring the 3 down front. It's going to be 3 times x to the 3 minus 1, or 2 powers, so 3x squared. And so that's going to equal 3x squared times e to the x cubed. We're asked to evaluate the following limit, and it's the limit as h approaches 0 of the cosine of pi over 6 plus h minus the cosine of pi over 6 all over h. Now, it would be really tempting to go into limit mode and use trig properties to expand this cosine pi over 6 plus h and possibly see if we can get this limit to simplify and stuff like that. But if we think about it, we take a pause, we notice that we see a function. We see an x value, and we see some h's. And so we can quickly notice that this is in the pattern. Oh, I missed an h. We can clearly see that this is in the pattern of the definition of a derivative. This is just the definition of a derivative. So all it's asking us is to find the derivative of cosine function at pi over 6, at x equals pi over 6. So simply we can just evaluate that. The derivative of cosine is negative sine. And we want to evaluate that at pi over 6, and sine of pi over 6 is 1/2, but it's negative pi over 6, so the answer is negative 1/2. Also check out, I didn't list it here, but also check out, I'll write down real quick, derivatives of trig functions. If you're confused on how I got from cosine negative sine, make sure you review your derivatives of trig functions. Find f prime of x if f of x equals the natural log of 3x. Again, this is another problem where we need to know what the derivative of the natural log function is, so make sure you can review your logarithmic functions. Obviously, it's a chain rule problem, because why would we not use the chain rule and practice the chain rule? The derivative of the outside is the natural log of x, so that's 1 over x, but the inside is going to remain unchanged, so it's just going to be 1 over 3x times the derivative of the inside. The derivative of 3x is simply just 3. You're going to get yourself 3 over 3x, or that simplifies down to 1 over x. The other thing you can remember is because this is the natural log function, we can use our little cheat sheet that we created using the chain rule, and that whenever you take the derivative of the natural log function, the chain rule is just going to make it. You can just worry about the inside. Take the derivative of the inside, stick it in the numerator, and then move the inside to the denominator. So the derivative, if we let u equal 3x in this case, because that's the inside of the natural log function, the derivative of 3x is just 3. That goes in the numerator, and then the inside, which is 3x, we'll plop that in the denominator. The 3's will simplify, divide to 1, and we'll get 1 over x. Same answer. You could do it. You could choose to do it either way, and either way would get you the same answer. Find the approximate value of f prime of 3. Well, we're wanting, the f prime of 3 is the slope of the tangent line at x equals 3, but the problem is we don't know what f of x is, so it's really hard to find the slope of this tangent line when we're only given 1 point on the line. And in fact, we're actually given 0 points because we don't even know the y output at x equals 3. So what we're going to do is we're going to approximate it using the slope of the secant line through the points x equals 2 and x equals 4, because if we look at the slope of this blue line, while it's not exactly the slope of the orange line, it's pretty close to the slope of the orange line. So we'll just find the slope of this blue secant line, And, well, the slope of a line, we're given 2 points, so it's just a rise over run. So y2, which is f of 4, minus y1, which is f of 2, over x2, which is 4, minus x1, which is 2. F of 4 is 3, f of 2 is 1, 3 minus 1 is 2, 4 minus 2 is not 1. Oh my gosh. 4 minus 2, I'm going to have to fix this. 4 minus 2 is 2. 2 divided by 2 is 1. My bad. I definitely missed that as I was making this. My bad. So f prime of 3 is roughly 1. Find dy dx if x cubed plus y cubed equals 6xy. Now, hold up a second. I want to fix something really quickly. I wanted to add another big idea before I got started. So I read the problem. What we're going to do is, remember, this is defined implicitly. It's not defined explicitly. So we can't just go straight to finding the derivative of y with respect to x. But the easy thing we can do, as long as we remember that the derivative with respect to x of y is simply dy dx, which is what we're trying to find, we can just take the derivative of both sides just like normal and just see what happens. So by doing that, I'm going to work from left to right. The derivative of x cubed with respect to x, bring the 3 down front. It's going to be 3 times x to the 3 minus 1 power, or x squared. Here we've got a chain rule, because remember, y itself is a function of x. So we really have a function within a function. We're going to do the outside function, bring the power of 3 down. The inside y remains unchanged, reduce the power by 1, y squared, times the derivative of the inside, the derivative of y, is dy dx. And I marked it in red because that's what we're trying to solve for. The right-hand side, I noticed that there's a constant multiple of 6, so I'm going to pull that 6 out in front as I take the derivative of x times y. Now, that's the product rule. So we're going to take the first, which is x, or the first value, which is x, multiply it by the derivative of the second value, the derivative of y is dy dx, add it to the second value, which is y, times the derivative of the first value, which is simply 1. So that'll all simplify down to 3x squared plus 3y squared dy dx equals 6x dy dx plus 6y. I marked the stars that you saw where I carried over again. So what we're going to do is I'm going to move, there's multiple dy dx's. I want one singular dy dx. So my goal is I'm going to try and factor out a dy dx. In order for me to factor out a dy dx, all the dy dx terms need to be on one side of the equation. I chose the left side, as you can see, and everything else needs to be on the other side of the equation. So doing my magic algebra skills, I rearranged this, as you can see here, and then factored out that common factor of dy dx, and then divided by 3y squared minus 6x, and I got 6y minus 3x squared over 3y squared minus 6x, but notice there was a common factor of 3, so I factored out 3. The 3's ended up dividing to 1, and I got that the derivative of y with respect to x is 2y minus x squared divided by y squared minus 2x. I know that I went through this problem that's super complicated, super fast, so if you're confused, check out my implicit differentiation video, and also I used the product rule once right here, so if you were confused by what I did right here, check out the product rule. We're asked to evaluate this limit. The limit is x approaches 2 of x squared plus x minus 6 divided by x squared minus 4. Plug in 2, I get that 2 squared is 4, plus 2 is 6, minus 6 is 0. And then I get that 2 squared is 4, minus 4 is 0, so I have type 0 over 0. I want to write that down. Type 0 over 0 for this limit. This limit is indeterminate, and we learned in this video that we could simplify this and factor it out, or we could choose to invoke L'Hopital's rule, which is take the derivative of the numerator and take the derivative of the denominator, and then see if you can evaluate the limit. The derivative of x squared is 2x, the derivative of x is 1, and the derivative of a constant is 0. The derivative of x squared, again, is 2x, and the derivative of a constant is 0. This limit is not indeterminate. We can evaluate this limit, and that limit comes out to be 5/4. So there you have it, guys. That is my video on Big Idea 2, differentiation, basic differentiation stuff. We're going to get it in less than 10 minutes. That makes me very happy. Thanks for watching. Definitely hit that subscribe button so that you can get more of my calculus content or any of my other math content I make as it comes out. Leave a comment and also leave a like if you found this video to be helpful. I'd love to put this video into the hands of other people who need and want this help. And I also want you guys to know that you are brilliant and amazing and so talented, and even if you don't pass this AP exam, do not let an AP test score define who you are. You're still going to get to go to the college of your dreams, and you're still going to rule the world with your amazing math skills. So don't worry about the AP test score. Go into it with everything you know and be super super confident and happy when you leave the AP test. With that said, thanks for watching, and I'll see you all in the next video.